Before we get into this video, I just want to say a giant thank you to patron Eric, who donated a ginormous amount of parts. I'm talking Noctua fans, MGN20 linear guide rails, T8 lead screws, dozens of stepper motors, servo motors, Arduinos and displays, pneumatics components, ball bearings, linear rods, and other printer hardware. Yeah, he's clearing out his shop to move overseas, but I still can't believe I ended up with all this. Anyway, let's build our laser engraver / cutter using crappy stepper motors like you can easily salvage from common e-waste. I do have more than enough steppers now to do it properly, but like I said in the project introduction episode 0, here it is if you haven't watched it, this thing's been in development for so long, I cannot do a full 180 now. And if I scrap it entirely, I won't have any videos till I've redesigned a new one from scratch. Plus, the first of anything we build is usually crap, so let's get it out of the system, hoping I can build something better and arguably less entertaining in the future. So the parts I just made are going to be the main mounting points for the linear rails and lead screws. As a result, the holes I need to drill into them need to be as equally spaced from the bottom edge as possible, otherwise I risk putting the entire gantry askew with respect to the cutting area and having the Z height of the focal point all over the place. To have any chance at actually achieving this, I made a single-use drill jig from some scraps to help me guide the drill bit and position those holes where they should be, because just center punching and drilling straight in ain't gonna cut it. To be fair, strictly speaking, none of these holes really needs to be positioned more accurately than within 0.5 millimeters. The two lower ones for mounting the linear rails are actually oversized to allow for adjustment later, but the two upper ones, which are technically just clearance holes for the lead screws, will double up as pilot holes for drilling the recess the ball bearings go into, and since those better be in the right place, I have to do my best to get the through hole position correctly as well. 81.19, 81.21, oh my gosh, this totally worked, I'm within 500ths. Okay, the next step will be machining a pocket for the bearing to sit in. I unfortunately don't have a 16mm Forstner bit, otherwise I'd have used that in my drill guide just now, so the next best solution I could come up with was a step drill. It's not ideal because it'll unnecessarily ream my 8mm hole out to 14, but technically that doesn't impede functionality, and at least the step drill shouldn't wonder. So short of running out to buy a Forstner bit, that's the best I can do. I really hope this works, otherwise I need to shuffle things around a little bit or even remake the entire part. Yeah, it's not a great design unless you have a CNC router to make this part really accurately for you. It fits, though I have to line the hole with tape to make it a press fit. Of course, the HDF being mostly fibers with a very low glue content, it made a total mess of it. But it'll do, so I can go ahead and cut some of the other parts I need. I get those HDF panels for free, so while they're more of a pain in the ass to work with than MDF or plywood, it's worth the satisfaction of having reused something destined to scrap. Now, this particular part needs to have 22 slots spread evenly over most of its length, so I'm gluing on a printout template rather than trying to measure out 23.6mm over and over on a ruler. You know what would be real handy to do things like this? Some kind of computer-controlled robot that could cut parts out of thin sheets using like a super strong laser or something. I know, crazy idea, huh? Now, because simple butt joints have basically no strength at all with this glorified cardboard, it just pops right off, tearing up the surface, I'm going to retroactively install some toothpicks as super thin dowels. And as you can see, I had the foresight to place one of the pinholes for cutting those slots simultaneously exactly where I now put the dowel, so it's plugged. It's not as if it would even matter if there were like 20 random holes in this part, but you know, tidiness is one of my obsessions. Also worth mentioning, this joint doesn't technically even need to be strong. The entire frame will get glued to the base plate at a later point, but until then it needs to be handled quite a lot, meaning I'd probably manage to break it. Ultimately, these much thicker end plates will get permanently glued to the frame as well, but for now, since I still need to take them off several times to drill holes using the drill press, I'm just gonna screw them on instead. Well, this is coming together really nicely. As you can imagine, this here is the border for the cutting area. The empty space over there is going to be filled with the power supply and the air assist pump and whatnot, while the actual surface for cutting on will be made up of a whole bunch of consumable slats I cut from 2mm HDF earlier. These just slide into the slots like so, which is also the reason I had to glue on these liners to prevent them sliding around and potentially falling off or interfering with the carriage or whatever. And there we go, exactly like on a water jet cutter. Now I can plonk a piece of plywood on top. It's admittedly a bit more wobbly in X than I imagined, but with lasers exerting no cutting forces, it should be fine. I did briefly consider making the entire bait out of these cardboard tubes, cut up and glued into sort of a honeycomb structure, but some back of the envelope math told me I'd need over 20 meters total of these tubes, which I don't happen to have readily laying around, so that didn't happen. Though for all I know, you could probably use toilet paper tubes as well. Just don't cut anything tiny that can fall in and be fiddly to pull back out. Anyway, with the main frame and bait done, it's finally time for the gantry. The linear rails will be made from 20mm aluminum square tubing, and because cutting up short 1-meter sections leaves me with pretty useless, not even 1 foot long pieces, I went the extra mile and purchased a 2.5-meter one. Getting this back home, the 7 miles from the hardware store, on my bicycle, without bending or scratching it, wasn't exactly fun. Except for the old lady who chuckled when she saw me riding that broomstick. So from this much longer stock, I can easily cut all the rails I need for this machine without creating harder to use offcuts. Now, importantly, this square tubing is anodized, because as we learned from my 3D printer, raw aluminum is so soft it quickly rubs off and gets worn down even by plastic wheels, which is kind of ironic. To get these abysmal handsaw cuts remotely square, I'm gonna do something very not recommended, so don't try this at home nor at a friend's place. I'm just going to trim them down on the table saw. This is a very bad idea because this blade is not meant for metal. It won't dull because it's carbide tipped, but it might still jam and or explode a tooth if I get my feed rate jerky in any way. That went a lot better than expected. I'm always surprised by how well you can just cut aluminum with woodworking tools. Oh shit, I cut it too short. Nah, just pull in your leg. I made it a millimeter shorter on purpose to account for A, thermal expansion of the aluminum rails, and B, much more importantly, expansion and contraction of the entire frame caused by humidity, because assuming this HDF expands by just 0.5% from 30 to 90% relative humidity, which is about in the ballpark of expansion coefficient values I found for MDF, over this length, my frame would get almost 4 millimeters longer. And since we're currently having a bout of absolutely atrocious weather, basically drowning in almost daily rain since March, which unsurprisingly pushed humidity here in the basement to an all-time high, I would actually need to make my rails 4mm shorter to allow the frame to fully shrink with drier weather. And these numbers don't even seem far-fetched at all, because I just noticed this gap looks a lot more like 2mm than 1, which, in fact, it is. Yet, I double-checked these rails, and they're the right length, so what gives? Well, checking the frame turns out it's over 0.5 millimeter longer than it should be, even though I'm confident I cut these parts correctly, and there isn't really any gap in the joint on either side. Sure enough, humidity is about 5% higher now than I remember it being a few days ago when I worked on the frame. So making the rails just 1mm shorter is actually quite conservative, but I think I'll risk it because I can still just trim them down some more later, and I haven't seen humidity in here dip much below 60% over the past year. Also, completely unrelated, PCBWay, who are sponsoring this video, just introduced UV color printing on circuit boards. I'm gonna assume at this point everyone watching my videos should know that they are a leading PCB and manufacturing service provider. If not, oh my gosh. But UV printing basically allows you to have full color images or designs printed directly onto circuit boards, which was never possible before. This is really great for any PCB art like these Christmas ornaments for us nerds. Yes, I didn't know PCB art was even a thing, but turns out it is, and I really like it, especially when there's LEDs involved. Actually, getting this on your circuit board seems fairly straightforward. Basically, you just need to include the image to be printed, as well as a reference file specifying where exactly on the board the picture should be located in the zip folder with your gravers, and proceed as normal to place the order, except for toggling one of these buttons. This whole offer is still in beta testing, so things may possibly change somewhat over time, but the link is in the description. So big thanks to PCBWay for sponsoring, and back to my petty attempts at engineering an expansion joint for mounting aluminum rail in an overrated cardboard box. As you can imagine, with the entire frame lengthening and shortening at the whim of humidity, rigidly attaching aluminum tubing that doesn't expand as much is just asking for trouble. And I'm ashamed to admit that addressing this issue was basically just an afterthought I had, which I'm now slightly tweaking the design for. My original idea was to just make a simple block of wood with a bolt in it to attach the rail to the frame like this, which works fairly well, even allowing the rail some linear freedom of movement to make up for dimensional changes of the frame. But what if this block expands? It would get permanently stuck in the tube, causing my automatic telescoping mechanism to stop working. Well, that's at least easy to solve. I have a 3D printer, and plastic doesn't expand. At least not substantially enough to cause problems here. So let me get you back up to speed on this printer. As you can see, since the last video, I printed a few parts to make the X and Y axis lead screws spring-loaded, and ever since I did that, I haven't had a single print fail due to the motors stalling mid-print. However, to get there, I also had to super glue the plastic tubes I used as lead screw couplers to the motor shafts, because unsurprisingly, the stepper motors get pretty toasty, which made the plastic tubes soften and relax their press fit on the motor shaft, leading to slippage and layer shift on prints with more complex geometry requiring the motors to spin very slowly. Now though, it's surprisingly reliable for a printer this crappy. I also ended up printing some motor cooling ducts and attaching fans to the X and Y motors to keep them a little bit cooler, as well as getting rid of the terrible Linux netbook with its broken Repetier host install. And I'm now running Octoprint on the Raspberry Pi Ericsson, which I was conveniently able to mount to the wall behind the monitor. I still need to install Octodash for the screen to display something slightly more exciting than white text, of course, and to actually be able to control the printer locally using the mouse and keyboard. But I even went as far as to add a webcam. This is one of these super cheap little cube action cams I had laying around. The LiPo in it puffed up and got surgically removed years ago, but plugged into USB, it still works perfectly as a webcam, so of course I had to print a little attachment clip for it. And honestly, a live video feed of my 3D printer on my phone was exactly what I didn't know I needed until I had it. At this point, it's really just missing RGB LEDs. So anyway, here's the part we're going to print. It has rounded corners because my printer is still prone to making corners bulge out a little bit, possibly because I still couldn't be bothered to tune it properly. In the middle there's a printed M6 thread for a stud to mount it with, so let's get it sliced and sent down to the printer. I have to say, when I first tried out Octoprint, I was quite unimpressed, because let's be honest, without installing a few plugins to make the UI proper usable, it's nothing to write home about. I do need 4 of these in total, but I'm printing them consecutively because this printer is, and probably always will be, prone to stringing thanks to travel moves being so slow. I mean, printing at 25mm a second isn't terrible, but when it can't move any faster than that to get the print head from point A to point B, there will always be blobs and oozing no matter what I do with retraction. At least that's what I gathered from a comment on the last episode. So that's bad news for more complex geometries, but some slicer tweaks like avoid crossing perimeters and printing parts back to back instead of concurrently can still go a long way toward getting surprising results from this printer. Okay, here's the parts. I made them ever so slightly oversized so that I can manually sand them down to a perfect fit. Here we go. It's still a rather tight press fit, but I'm gonna rely on PLA's propensity to mechanical creep to relax some of that tension and make it a snug sliding fit like it's supposed to be. On the flip side though, it just occurred to me that the upshot of this very phenomenon might result in the screw connection with the frame not lasting either, because I imagine if PLA under stress tends to slowly squish over time, it'll also simply compress the plug this way to relax the screw tension, making my rails go all loosey-goosey after a while. So I might ultimately need to reprint these parts with a stronger filament, but for now, let's see how long we can get away with it. I might also have to reconsider each plug featuring its own thread to be mounted with rather than a threaded insert or something for a screw to grip onto from the other side, because the way it is now, I virtually cannot install the X-axis rails without unscrewing one of the mounting plates, which, like I mentioned earlier, will eventually get glued in place. As you can see, these mounting holes are amply oversized to allow for some decent horizontal and vertical adjustment of the linear rails to get the entire gantry level and whatnot. Now, you might think that because my holes ended up decently accurate after all, this might be more of an inconvenience than actually helpful, but because the horizontal position of my lead screw bearings isn't accurate, even though the lead screw nut will be a fixed distance from the carriage, I actually need to be able to adjust the linear rail relative to the lead screw, if that makes any sense. Never mind, adjustability on this machine is really convoluted. It's probably an overly complicated design for what it's trying to achieve. Anyhow, so next up are these side pieces for the X-carriage, and again, those would be ideal candidates for 3D printing because anything you manage to make accurately enough, you don't need to make adjustable. And I even went as far as to redraw those parts in FreeCAD in order to convert them into STLs, but then scrapped that idea entirely, seeing as it's A, a rather large part that I definitely wouldn't want to have to wait for to print on my slow DIY printer, let alone twice, and B, because the entire machine was originally intended to be possible to make without a 3D printer, and I only recently started to add 3D printed parts out of convenience, it feels like a huge waste of material and potential to make a machine capable of producing the most elaborate of parts spit out a crude block that I might as well have chopped out of a tree trunk using a hacksaw. I guess that was a little bit more than hacksaw levels of woodworking, but in case you didn't guess it already, the prime reason for machining these two parts in one piece and then taking them apart wasn't to save time, although that's an appreciated bonus of course, but to ensure that important holes are in the exact same position on both parts. Case in point, this hole here single-handedly dictates the position of the entire y-axis linear rail, and the bigger one, the lead screw, if they're not precisely the same distance apart, my linear rail and lead screw won't be parallel, which would be disastrous because as per my design here, they're not adjustable. With the two parts separated, I can add some of the few features that aren't shared by both, like mounting holes for the y-axis stepper and a recess for the single ball bearing supporting the non-motorized end of the lead screw. Then, after adding some boring, but nonetheless time-consuming counterboards off-camera, I can glue on the risers for the POM wheels to sit against. Because those risers obviously didn't have any holes yet, I need to push those through from the other side before I power tap them on the drill press. Now, this is a bit riskier than the other methods of starting a tap straight using a drill press that I've shown on this channel previously, but in this case I figured it would take too long and I'm lazy, so I just set it to its lowest speed, and because I need both hands to hold the part and feed the quill, I have the drill press plugged into a switch power strip, allowing me to quickly turn it off with my foot. Now ain't that something, I even purchased the right kind of screws this time. I hope you guys are proud of me for not using wood screws. And yes, that is exactly the bag they came in. Now, I'm gonna be first to admit, yes, 4 wheels per carriage on a laser is overkill, but the entire thing is over-engineered to a degree for no good reason. I mean, look at these plates. They could have been 8mm, but I went with 12. It's pretty hefty. Also, as you just saw, there is no eccentric nuts to adjust the wheels. Like on, for example, a 3D printer, it's really just the spacer they're mounted to sliding up and down in those slots, which lets me push the wheels up against the rail and tighten the nuts. Considering how incredibly simple it is, this works amazingly well. Plus, had I used a single third bearing, it would have gone in the middle, so I could have either had a weird wooden washer as a second spacer, or tons of unnecessary wood flopping around on either side, both of which might have made adjustments awkward. Furthermore, you might have noticed, as opposed to my 3D printer, the wheels are fixed. They are not spring-loaded because with an aluminum rail, we don't need to compensate for it expanding and contracting with humidity. Yeah, the carriage is still wood, but over such a short distance, the effect should be in the microns and negligible. I genuinely love how smooth these are. So the y-axis is pretty simple at this point. You might have seen 2 more of these plugs sitting on the bench. I printed these in advance, so now I just need to cut the rail to length and mount it. This time the plugs are supposed to be a press fit, although not to the degree of having to hammer them in and risk actually stretching the aluminum tubing. Then I'm driving a bolt into the printed thread from the outside, rather than having it go through the entire plug and securing the other end with a nut like on the X-axis. And yup, this bolt is totally too long, but I cannot be bothered to go out by the right length. Also, these roofing bolts have a really nice large truss head, eliminating the need for a washer, and they are aesthetically pleasing and all, but the drive on them really isn't made to fit any practical screwdriver, so whatever you end up using tends to constantly slip. Now, I think this would totally work as is, but to add some additional rigidity, just because I have it sitting around really, I'm going to install this piece of thinner square tubing as well. This is a leftover from the second table saw I built, hence why there's holes in it, but in this case it'll just provide something for the drag chain to rest on. And since this tube doesn't need to stay accurate to serve double duty as a linear rail, I can hammer in the plug to my heart's content. Yeah, that ain't going anywhere. Finally, for the Y-carriage, I took the liberty of preparing it entirely off camera, seeing as it's pretty much identical to these other ones, just smaller. Worth noting here is that I made it from MDF scraps rather than Baltic birch plywood, because it's really just meant to be a temporary solution for testing and a nice thumbnail picture. At the end of the day, I want this machine to have a motorized Z-axis for raising and lowering the focal point of the laser, just because why not? So this entire carriage will become much more complex with its own linear rail and stepper, and totally worth 3D printing. In fact, I rushed through making this so badly, I somehow managed to drill these holes in completely the wrong spot, especially this one here, which I had to re-drill down there because I jotted down the line at the wrong centimeter mark. Yeah, you see, this smartphone holder style clamp for attaching the laser, as nice as it is being made from aluminum, is kind of a pain in the ass to move the laser up or down. You have to grab an Allen key each time, and the gantry has to take all the forces from fiddling about tightening and loosening the screw. And there we go. Honestly, seeing how incredibly smooth this linear rail system is, I'm really starting to regret I ever decided to make this machine lead screw based instead of going for the standard Nema 17 direct belt drive. More on the ins and outs of the impossibility to retrofit next episode, but suffice to say, in for penny, in for pound, it's gonna have lead screws because the few disadvantages they entail aren't worth redesigning the entire machine this instant. In the long run though, I do intend to fully redesign these X-carriage columns to fit a Nema 17 by taking full advantage of 3D printing, just so I can confidently publish this machine as an open source project. Lead screws are fun and interesting and all, but ultimately Nema 17s with tooth belt win out for being much lower maintenance, possibly just as cheap, and a lot easier to get it working. I mean, when I designed this laser, I couldn't know that I would now have a box full of decent stepper motors, as well as dozens of feet of GT2 belt laying around. So, I hope you enjoyed this first episode. I'm sorry it took this long, but we got a surprising amount done for a video of mine. Which of course didn't help since it meant a lot of off-camera work that didn't contribute to video length as well as talking usually does. Special thanks to all the folks supporting on Patreon, making this stuff all the more possible, especially Eric with his huge donation. I guess my projects won't be as bottom of the barrel as you're used to seeing anymore. Bye bye!